Bismillahirrahmanirrahim. Assalamu alaikum students. This is your chemistry teacher Farzana Nazir. Today we are going to discuss our last topic of chapter 5, physical states of matter. Today we are going to discuss solid states of matter. We are going to discuss different types of solid like crystalline solids and amorphous solids. We will discuss about quartz. We will study the difference between crystalline and amorphous solids. We will study about allotropes, and we are going to study the different allotropic forms of carbon, phosphorus and sulfur. After going through these topics, students will be able to classify different solid substances on the basis of their properties. They can easily differentiate between crystalline and amorphous solids. They can also explain the allotropic forms of solids. Solid state. If we look around us, we will find that most of the substances exist in solid form, like table, chair, bottle, car, mobile, etc. Even water, which is a liquid, can also exist in solid form like ice. Most of the mineral substances which are present in our earth crust are solid in nature. If we look at the particle nature of solid, unlike solid, the particles in solid are not free to move. They are closely packed and can only vibrate about their fixed position. That is why solids are very hard and have fixed shape and fixed volume. Types of solid. On the basis of arrangement of particles, solids are classified as crystalline solids and amorphous solids. Crystalline solids. A crystalline solid is a solid that is composed of orderly, repeating, three-dimensional arrangement of particles. This means a crystalline solid has well-defined shape because of the orderly arrangement of its particles. Crystalline solids have sharp melting point. The below figure shows the shape of sodium chloride crystal. Notice that sodium ions and chloride ions are close and packed together in regular array. Examples of crystalline solids are copper sulfate crystals, common table salt NaCl, and gemstone. The second type of solid is amorphous solid. An amorphous solid is one that lacks ordered arrangement of its particles. This means it does not have a well-defined arrangement of its particles. Amorphous solids do not melt at definite temperature but gradually softens when heated. Examples of amorphous solids are rubber, glass. Even different metals exist in amorphous forms. Quartz. Quartz is a macromolecule and its simplest unit is SiO4. Quartz also exists in crystalline form as well as in amorphous form. In crystalline form, if you see the structure of quartz, all the atoms are arranged in a particular repeating three-dimensional arrangement. As a result, the quartz crystals have definite shape and they are shiny. Whereas the amorphous form of quartz is called quartz glass. In quartz glass, as you can see, the particles are irregularly arranged. Quartz is the crystalline form of silicon dioxide. It is a hard, brittle and colorless solid. When quartz is heated above its melting point about 1600 degrees centigrade and cooled rapidly, an amorphous solid called quartz glass results. Difference between crystalline and amorphous solid. Crystalline solids possess ordered arrangement of its particles, so they have definite shape. Amorphous solids lack ordered arrangement of particles, so they do not have definite shape. Crystalline solids have repetitive array of particles, whereas amorphous solids have non-repetitive arrays of particles. Crystalline solids have sharp melting point, whereas amorphous solids melt over a wide range of temperature. Examples of crystalline solids are NaCl crystal, diamond, whereas examples of amorphous solids are glass and plastic. The next topic of our today's lecture is allotropes. Some elements can exist in two or more different arrangements of atoms. The different forms of elements in same physical state and phases are called allotropes. Allotropes of a particular element exhibit same chemical properties but different physical property. In the following figures, you can see that there are different forms of an element. The first picture is about carbon. Carbon can exist in different forms. All the forms have same chemical properties but different physical properties. The second figure is about the allotropes of phosphorus. As you can see, the different forms of phosphorus have different colors. This is due to the arrangement of phosphorus atoms in its molecular structure. Allotropes of carbon. Carbon exists in three allotropic forms. First, diamond. Second, graphite. Third, buckyballs. Now let us study these three types in detail. Allotropes of carbon. Carbon is well-known non-metal atom which is present in different forms in nature with wide variety of properties. It is abundantly present in earth crust. Carbon exists in two forms, crystalline and amorphous. In crystalline form, the particles are arranged in definite order, but in amorphous solid, particles have no definite order of arrangement. Coke, coal, and charcoal are the amorphous forms of carbon, whereas diamond, graphite, and buckyball are the crystalline forms of carbon. Both these forms are called allotropic forms of carbon. Allotropes are the forms of same element which exhibit different physical properties but with similar composition. Carbon. Let us study the crystalline form of carbon. Diamond. It is the hardest crystalline form of carbon. In diamond, each carbon atom is linked to 4 other carbon atoms by covalent bond, forming a rigid, compact, three-dimensional structure. Due to the absence of free electron, diamonds are bad conductor of electricity. Diamond has high melting point. They melt above 4000 Kelvin. Now let us study another crystalline form of carbon, that is graphite. In graphite, each carbon atom is bonded to 3 other carbon atoms by covalent bond, resulting in hexagonal ring which are arranged in layers one above the other. Graphite is good conductor of electricity due to presence of free electrons. Due to its structure, graphite is flexible and it is soft. The layers in graphite can slip past each other. Therefore, graphite leave black mark on the paper. It is not hard as diamond and it is grey and greasy. It melts above 1500 degrees centigrade. The third allotropic form of carbon is fullerenes or buckyballs. Buckyballs of fullerenes are formed by the combination of large carbon atoms. The first one to be identified was carbon-60. Its structure has been established on the basis of investigations carried out by Buckminster. Therefore, it is also called fullerenes. The shape of buckyball resembles soccer ball with 6 member as well as 5 member rings. There are 12 5-member rings and 20 6-member rings. Allotropes of phosphorus. Phosphorus also exists in 2 allotropic forms, that is red phosphorus and white phosphorus. Let us study these allotropic forms of phosphorus in detail. If we look at the match head, it is usually red in color. This is due to the presence of red phosphorus, an allotropic form of phosphorus. In red phosphorus, P4 molecules are bonded to one another in long chain. Matches made up of red phosphorus are known as safety matches because they can be ignited by rubbing it against the matchbox. Before the introduction of red phosphorus, matches were made up of white phosphorus, another allotropic form of phosphorus element, which is white in color. The difference in color is due to their internal structures. These matches can be struck anywhere for ignition. Since this allotropic form of sulfur is significantly inflammable, therefore they are very dangerous to use. Therefore, they are slowly replaced by red phosphorus. White phosphorus consists of P4 atoms which are held together in tetrahedral arrangement. Allotropes of sulfur. Sulfur consists of molecules that contain 8 atoms S8. Sulfur also exists in several crystalline and amorphous forms. Rhombic and monoclinic forms are its important crystalline forms, whereas plastic sulfur is the amorphous form. Now, let us summarize what we have studied today. Solid consists of array of particles which may be atoms, ions, or molecules. Crystalline solid is composed of orderly repeating three-dimensional arrangement of particles. Amorphous solid lack ordered arrangement of particles. Different forms of an element in the same physical state or phase are called allotropes. Allotropic forms of carbon are diamond, graphite, and buckyball. Allotropic forms of phosphorus are red phosphorus and white phosphorus. Allotropic forms of sulfur are rhombic, monoclinic, and plastic sulfur. Now, at the end of today's lesson, I am going to give some questions for you to exercise. Question number 1. Classify the following substances as crystalline or amorphous in nature. I hope you can easily differentiate between these two types. You are provided with glass, graphite, plastic sulfur, common salt, diamond, rhombic sulfur, and quartz. Question number 2. Draw the allotropic forms of phosphorus.